Hello everyone, myself Mukund Ramprasad Soni. I am student of Arihant College of Education. I am pursuing B.Ed second year under Savitribai Phule University, Pune. For this session, the student need to know the basics of number system like fractions, decimals, natural number, integer number, rational number, irrational number, etc. And also how to do division with decimal points, without decimal points, and also subtraction and tables.
Solve the following. 42 divided by 7 is equals to how much?
You can pause the video and try. Once you are done, you can resume the video and check your answer.
And the correct answer is 6.
What is the quotient and the remainder if 14 is divided by 4?
You can pause the video and try. Once you are done, you can resume the video and check your answer.
Let's solve it together, as 4 is divisor and 14 is dividend. Then 4 3s are 12, 3 is a quotient, and 12 will be subtracted from 14. Hence, the remainder is 2.
And the correct answer is
The quotient is 3 and the remainder is 2. Find the quotient with leaving 0 as remainder. If 20 is divided by 8,
You can pause the video and try. Once you are done, you can resume the video and check your answer.
let's solve it together. 8 is divisor and 20 is dividend. 8 2s are 16. Hence 2 is quotient and 16 will be subtracted from 20, leaving 4. Then, as the division is not completed, we must take a decimal point and followed by 0. Then move the decimal point into the quotient and 0 next to the 4. Then 8 5s are 40. Then 5 will be quotient and 40 will be subtracted from 40 and remainder will be 0. This is how the division completed. I hope you have got the right answer. Therefore, the final answer is 2.5. Today, we are going to learn decimal form representation of rational number, terminating decimal form, non-terminating decimal form. Decimal form representation of the rational number. 7 divided by 4 is equals to 1.75. 7 divided by negative 3 is equals to negative 2.333 and so on. Negative 1 divided by 100 is equals to negative 0.01. Negative 1 divided by negative 37 is equals to 0.027027 and so on. Negative 50 divided by 5 is equals to how much? And also 221 divided by 15 is equals to how much?
You can pause the video and try. Once you are done, you can resume the video and check your answer.
And the correct answer is
Negative 50 upon 5 is equals to negative 10. 221 divided by 15 is equals to 14.7333 and so on. These all examples are decimal form representation of the rational numbers. Observe the examples on left hand side. These are the examples in which the answers are terminating, which means these answers having no repeated digits. On right hand side, the examples are shown with repeated decimals or repeated digits. Both type of examples are applicable examples of rational number in decimal form representation. Observe closely. 7 divided by 4 is equals to 1.75. Negative 1 divided by 100 is equals to negative 0.01. Negative 50 upon 5 is equals to negative 10. Terminating decimal form. If we use decimal fractions while dividing the numerator of a rational number by its denominator, we get the decimal representation of a rational number. For example, 7 divided by 4 is equals to 1.75. In this case, after dividing 7 by 4, the remainder is 0. Hence, the process of division ends. Such a decimal form of a rational number is called a terminating decimal form. Few more examples are as following. Representation of terminating decimal form. We know that every rational number can be written in a non-terminating recurring decimal form. The examples which are given below, they are terminating and non-recurring in the form, which means no digit reappears in an answer as a recurring course. So why those are called non-recurring. But we can express it in recurring form. Observe the example. 7 divided by 4 is equals to 1.75. Negative 1 divided by 100 is equals to negative 0.01. Negative 50 upon 5 is equals to negative 10. 7 divided by 4 is equals to 1.75. Is also represented as 1.75000 and so on. We can put any number of zeros trailing to the 5, as those zeros do not add any value into the main answer. Now, as 0 is solo recurring digit in 1.75000, then it can be represented by putting a dot above the 0, like 1.750 dot, as shown in picture. So any digit which appears recurringly in your decimal representation can be reformed, such as the 0 shown in the green color, that is 0 point or 0 dot. The other two examples coming below will be following the same idea, and this is how one can represent a terminating decimal form into non-terminating recurring decimal form. Observe the following examples carefully. Negative 1 divided by 100 is equals to negative 0.01 is represented as negative 0.01000 and so on. Now we found as negative 0.010 dot. Negative 50 upon 5 is equals to negative 10 is represented in very similar way as above two examples. Compare the examples, observe carefully, and keep in mind 0 is a recurring digit, so why it is represented as 0 dot. If any other digit recurs, so they will be represented in the very similar way as the 0 represented in these examples. Observe carefully. To understand concept in more better way, we must solve few problems. Let's try an example from problem set 1.3. The question number 4, negative 103 divided by 5. You can pause the video and try. To check your answer, you can resume the video. The answer is as follows. In our question, 103 is dividend and 5 is divisor. In table of 5, 5 2s are 10, hence 2 is a quotient and 10 will be subtracted. Answer will be 0. Next number 3 will be taken down. 3 is smaller than 5, hence dividing 3 with the 5 is not possible. So we put a 0 in the question to get next digit. But as our dividend do not have sufficient number of digits, we shall put a decimal point and add more zeros to the dividend. Now 103.000, that is what will be our dividend. the decimal place will be shifted in the question and 0 will be taken down next to the 3. Now 30 is bigger than 5, so 5 6 are 30. The 6 will be questioned and 30 will be subtracted. The remainder will be 0. It represents the division is successfully completed. Therefore, the terminating non-recurring decimal form of our answer is negative 20.6, and the terminating recurring form of a decimal will be represented by adding extra zeros after 6 in our answer. Therefore, it will be negative 20.6000 and so on, which will be equals to negative 20.60 dot. Now you can see it is in recurring form of decimal. You can try more examples from the problem set of similar kind.
While writing an example, you should write it neat and clean. Steps should be clearly visible. Decimal points and dots also should be clearly visible. You should be neat and clean in your home and in the surrounding to maintain personal and community hygiene and health. Now we should move towards the next point. Now let's learn about non-terminating decimal form. This is a form of an rational number in which one can see the non-terminating decimal form, which means the answer of the fraction is non-terminating. Few digits are kept repeating as answer becomes endless. Like an example, when we divide 7 with 3, then we get result 2.333 and so on. Why we are keep getting these things? Because on doing this division, the remainder keep occurring and the same remainder keep appearing again and again. That makes it endlessly solving sum. This sum will not be finished because every time you will keep having the same remainder. We will see an example on it. Let us see more examples. Negative 1 divided by negative 37. On simplifying, we get the answer 0.027, 027, 027 and so on. So if you see, it comes with the pattern 027, 027 and 027. Now the very famous number pi, which is equals to a rational number 22 by 7. On solving that, one can find in answer 3.142857, 142857, 142857. It keeps appearing. That makes it another endless, non-terminating and recurring decimal form. Now let us see representation of non-terminating decimal form. From the previous examples, 7 divided by negative 3 is equals to negative 2.333 and so on. Now you see the 3 is the digit which is appearing again and again. In previous examples, we saw 0 was one of the repeating digit. As we spoke earlier, there can be other digits which can be recurring. That means repeating in your answer. Such numbers can be written as with point on their top, like -2.3 dot. Let's see another example. -1 divided by -37, which is equals to 0.027, and so on, which is again equals to 0.027 bar. Now see students, here there is not a single digit which is repeating. There is a set of 3 digits which are repeating. That is 027 itself. Hence, in final answer, for representing it as a non-terminating decimal form, we must draw a horizontal line on the top of the repeating digits or the set of repeating digits, as shown in example of -1 divided by -37, which is equals to 0.027 bar. Then another example from previous set, that is pi, which is equals to 22 by 7, which is equals to 3.142857, and so on. Were you able to find the repeating set of digits? If yes, then underline on it, and then your answer will be 3.142857, and it will be keep repeating and along with bar on it. I hope you have understood how to draw repeating digits and representing non-terminating decimal form. Let's solve an example on it. Let us solve example from problem set 1.3. Question number 1, 9/37. In answer, 37 is divisor and 9 is dividend. 37 zeros are 0. Subtraction will result into 9. As division is not completed, take a decimal point and put the zeros as many as you need. Now take the 0 down. 37 twos are 74. On subtracting, answer will be 16. Then take the next 0 down. 37 fours are 148. Subtraction will be 12. Take the next 0 down and keep doing it unless and until you find the remainder as 0. Now, do you see? The remainder is 9 again. Now, remainder is 16 again, and so on. We will find a 12 as a remainder again. Now, you see, this is coming again and again, which makes it repeated. You see, 160 appeared twice, that means it will appear again. Then 120 appeared twice, that means it will also appear again. And if I continue solving this, then definitely 90 will keep appearing again and again. Hence, the non-terminating recurring form of the decimal will be 9/37 is equals to 0.243243 and so on. Now, non-terminating recurring form of a decimal will be represented as 9/37 is equals to 0.243243. As 243 is repeating set of digits, hence in my answer 0.243 bar will appear. This division may be longer, but keeping a patience will definitely help you to overcome your fear in long calculations. It may find little stressful, but practicing more of this sum will help you to overcome your stress. Also, practicing the things in your day-to-day life which makes you more stressful can be overcome with practicing them and finding the new ways or easy ways to overcome your fear. Practice hard and keep trying. Do not pull back. So students, today we have learned decimal form representation of rational number and terminating decimal form and non-terminating decimal form and how to find them. Not to forget, keep practicing. Let's master your concept. Master yourself through these three examples. First question, how will you represent the single recurring digit? Question number 2, what is the decimal representation of 1 by 5? And third question, represent in recurring decimal form with appropriate symbols. E equals to 2.7, 182, 182, 182, and so on. The Google link given in the description and by your teacher. You will be able to answer this all question over there. Now, as you are mastered the concept, now challenge yourself through the following examples. Find the decimal recurring representation form of the division. First, 100 by 16. Second, 130 by 99. The same examples are given in Google form link as follows and by your teacher. Solve the answer over there only. Your homework will be solving the remaining questions from problem set 1.3. I know you don't like the homework, but I will tell you, solving the sums from this set will be very interesting to observe the repeating patterns of the digit. Submit your answers in Google form given by your teacher. And thank you everyone. Thank you for this session. I hope you enjoyed it and you understood the decimal representation form. Thank you.